Today's problem, minimum score by changing two elements. So low score, mean of the absolute value of I minus j, and high value is maximum value of the absolute of I minus j. To minimize the score, we can change the value at most two elements. So minimum possible score. In order to make the minimum, score is the sum, right? Yeah, so score is the sum of low and high, and we want to find the minimum score. So what this means is we want minimum of low and minimum of high. That's how you make minimum of score. Okay, that means we want the difference between I minus j, I minus j of absolute value. We want this to be as close as possible. Is that how this is gonna work? So the range has to be, for the mean, I and j, has to be close together. So minimum gap between I and j. What about this? We want maximum, or no, because we want high to be the minimum value as well, we want the same thing. So we want the gap between I and j to be the minimum, to be as low as possible, so that when we sum them up, low and high, they are still low, the minimum score. So how can I solve this? Let's take an example. So 1, 4, 3. Change value of nums 1 and nums 2 to 1, so that nums become 1, 1, 1. Can I change it to any number? We can change the value of at most 2 elements. So at most, I think at most is the keyword here. At most 2 times, or 2 numbers, 2 elements. Okay. So we can change. Then what do we know what to change to? So in this case, 1, 4, 3, mean will be the minimum low will be 4 minus 3 is 1. So this is gonna be the minimum. I the high score of num is the maximum value of I minus j. So it doesn't have to be the same I. The maximum difference is 4 minus 1, which is 3. So this is going to be 4 initially. Okay. So what does this mean? What does this mean? They can be the same or the minimum. The reason they changed 1 to 4 to 1, so they changed it to 1 1 1. Okay, so 1 minus 1 became 0, 1 minus 1 became 0, so the sum can be 0. What about the other example here? So 1 4 7 8 5. So in order to make the low will be 5 minus 4, which is 1. This can also be 8 minus 7. The largest difference, it was 8 minus 1, which became 7. So the score became 8, and it chose to change nums 0 and 1 to be 6. Now nums becomes 6 6 7 8 5. So 6 minus 6. Oh, okay. So because we can change at most 2 elements, we can always make low to be 0. Then it's just matter of finding how to lower high, right? So we can always make low to be 0 because we can change at most two elements. That means those 2 elements can be the same. Number to make low equal to 0. So this leaves us, now the problem is how to make high the minimum, the lowest. Well, if I want to make the high the lowest, I want to minimize the gap between the largest element and then smallest element. So I can try to find the largest element and change. Oh, it can either be largest or smallest. because we are finding absolute value. So in this first example, because 1 was the smallest, we changed these two, which was farthest away from 1, even though there were 3 elements. In this case, we could have chosen 1 or 8, because 1 is the smallest and 8 is the largest. Okay. And then let's say we chose 1. All right. And then so I'm thinking, why didn't they change? Oh, because there was no 6. Because my thinking process here is, if I could change 8 or 1 to 6, then if there was already 6, I could have made 8 to a lower number, so that 7 minus 4 becomes 3. So trying to understand why they chose 1 and 4 to become 6. Would there be any other choice here? It could have been, so 1 and 8 is farthest away. What if we chose it to, what if we chose it to be 5? Let's say we chose 1 to be 5, so that the low can be 0 with the other 5. Then 4 could stay, 7 could stay. We could make 8 to be some middle number, 5. Well, this would have been same, because there are 3, the difference. I feel like if I understand what number to choose, like the logic behind it, I can probably use like a binary search to find the right number. I cannot understand what the logic behind choosing either 1 or 8. In this case, we chose 1 because let's see. So 1, 4, 7, 8, 5. How would you know? What if I sort it? What happens if I sort it? If I sort it out, initial array becomes 1, 4, 5, 7, 8. Then in order to make high the minimum, I need to know I need to exchange the highest number and the lowest number. For example, I could, if the goal is making the high the minimum, I'll change this to like 4 and 7 to minimize the gap. Can I try to minimize the gap again, or in different way? Can I minimize in different way? I mean, why did they choose 6? They could have chosen 5. What if we just sort it and then make the high and low same as the number next to it? Let's try that. So I said I'm gonna sort it first. And then I'm going to change the nums 0 to become nums 1, nums minus 1 to become nums minus 2. And turn so what do we return? The minimum of the low will be always 0. Yeah, so we can just return nums, the last element, minus the first element. Okay, so let's take a look at the, I mean, it passes those two cases. All right. What if I submit it? Okay. So let's use this example. At least it passed 21 cases. Okay, so let's use this example to think about more. So the case is 31, 25, 72, 79, 74, 65. Okay, so if I do the logic here, it becomes 25, 31, 65, 72, 74, 79. So if I make what I wrote, it becomes 31, 31, 65, 72, 74, 74. But obviously this is not the right choice because the the left part or the right part is a lot larger, has a larger average than the left part. Right, this part has large gap between these two. That means if we chose these two be the same as this one, so it would look like 65, 65, 65, 72, 74, 79. The difference will be 14, which is the answer we had. 14 was the right answer. Yeah. Then how do we find this number? If I do the binary search, for example, over here, and compare the midpoint with the other ends, find the one that has a larger gap with the midpoint, which is this array. Then it will be 25, 31. So it will be 25, 31, 65 to process. Find the midpoint. What's the gap? So left array has less gap. Then it will be this number. So once we find that number, we can try to make using that number, we can compare with 79 and 25, and we know this has a larger gap. What if we update this number and then compare the next number? So 31 and 79. So this has larger gap, so we'll choose this one as well. How about that? Yeah, let's give it a try. So this is not going to work. So we are going to try binary search. Okay. So left pointer, R pointer will be 0, and length of nums -1. Do we also want to have equal? Yes. Yeah, we want to keep repeating until there's if L equals R, this num to change to will be I'll just say nums 0, and then we will eventually update it to become this number, the number that we find. Okay. Now we are going to find the midpoint. Okay. Compare with the left. If mid minus nums L is larger than R minus mid. What does this mean? This means the left subarray has larger deviation than the right subarray. Okay, so then we need to update the R to become mid -1, because we are searching on the left array. L if this is the other way around. What if they are the same? If they are the same, what does that mean? Left array and right array has the same. What do we do if they're the same? I feel like there's a consequence of visiting one or the other, but I'll just leave it like this for now. Okay. Or this can also be else case. Else case. So it's gonna keep updating until we reach L equals R. Once we find num to change, we are going to try twice. So if num nums 0, so this would be num to change 2 minus the gap between midpoint and the leftmost smallest element is larger than the gap between the last element and number to change to. This means there this means there's more gap between left then right. So we want to change the left number. Okay. And then we have to repeat this another time. Actually, else we need to update the last element. And we want to repeat this twice for a better chance to get the lower number. Then we return nums -1 minus nums 0. Okay, so let's try this out. This seems a little okay. So I'm going to run. Wait, how is output 0? Oh, wait a minute. How does output become 0? So 14785 becomes 14578. So it's gonna pick 5. It's gonna have larger deviation on the left array. So it's going to be 14. Do we also want to include the midpoint? Yeah, we also want to include the midpoint, I guess. So we don't want this to be -1. Okay, let's run this. Maybe it's stuck. Yeah. Oops. I don't know. This has to be -1. It's not gonna. I mean, it passes 5 test cases. It fails. So it's worse than the earlier solution. Yeah, I've spent too much time on this already, so I give up. Let's look at the solutions.